Well, howdy doody, and hello again, geographers. It's time for us to talk about virtual water. And what might that be? Let's find out. So we've got a couple of learning goals here. You're going to write these ones down. First up, obviously, you're going to know what virtual water is. Wouldn't that be useful? You're going to know what a water footprint is. That's not something you leave on the shower floor when you walk out. And you're going to be able to interpret a graph. Your activity is going to be a little graph activity. So, what is virtual water, I hear you ask, and I shall tell thee. Virtual water is all the water that's needed to make all the food and products we use. So whether or not it actually looks like you're using water, you are for certain things. And we've kind of talked about this a bit before. So like, you wouldn't think, oh yeah, my shoes, how much water do they use? There's no water in a shoe, but the water to power the factory, the water that the factory uses in the shoe factory, that all counts as water that's being used towards that pair of shoes. And if you add it all up, we use heaps of virtual water in all of our food and other products. Now, if you export products with high virtual water use, you're also exporting that water. And let me give you an example here. Australia, the driest inhabited continent, let's not forget, grows rice in the Murray-Darling Basin and exports some of that rice overseas. Now, to make 1 kilogram of rice requires 3,400 litres of water. That's 3.4 tonne of water, right? So that's 3,400 litres of water. That's virtual water. 1 kilogram of rice needs 3,400 litres of virtual water. So, if Australia exports 1 kilogram of rice overseas, what they're in effect doing is exporting 3,400 litres of water overseas because it's stored in that rice. It took that much water to make that rice. And so we're in this insane situation where Australia, the driest inhabited continent on the planet, is exporting water to other places that have way more water. And so that's why rice growing in Australia is quite controversial, because it uses heaps of water. So, on the other hand, countries that don't have much water can import high water use goods and export low water use goods. So, for example, Singapore. Singapore is a city-state. It's just Singapore and a few fields around it. It doesn't have a lot of water because it doesn't have a lot of land. And so it imports all of its food, which is made using heaps and heaps of virtual water. That's used to feed people who live in Singapore, and there's lots of industry in Singapore, and Singaporeans might export products that they make that doesn't use anywhere near as much water. And so they actually end up, through importing food and exporting manufactured goods, they end up essentially importing lots of water. And so that's why a country tiny like Singapore that you think, oh, it doesn't have enough water to support its population, it does, because it imports it in the form of food. Let's have a look at some how much virtual water is used for various things. You'd be quite shocked. So here we go. Here, barley and wheat use 650 litres for 1 pound. That's half a kilogram. This is American. Unfortunately, most of the internet's American, so they use these stupid imperial measurements rather than metric ones. But you kind of get the idea, right? So 90 litres of water needed to make 1 pot of tea. Look at beef though, 4,650 litres of water needed just for 1 steak, and that's only 1/3 of a kilogram. So crazy amounts of water. Basically, animal products use heaps of virtual water because it's inefficient to, and this is the answer to a homework question, to an activity question. The reason why meat and other animal products like milk and cheese use so much virtual water is because you feed the water to the animal and then you get another product out of the animal rather than just feeding it straight to a fruit or vegetable. It's inefficient, essentially. Here's some more things. So this is a really good comparison. Have a look at that. Even in a cup of tea, it takes 27 litres of water to make a cup of tea. Coffee, it's way more. Now look at that. Coffee takes a crazy amount of virtual water. So 17,000 litres of virtual water to make 1 kilogram of chocolate. That's even more than meat. So meat here, this is red meat. Chicken meat is much less, doesn't use anywhere near as much water. And then have a look along here. Actual vegetables and fruit doesn't use anywhere near these. The biggest use ones are animal products. I'm vegan, so that's not my problem. And this one here, so I remember how I was telling you about importing and exporting of water, which is embedded in products. So if you import food, you're importing all the water with it. And this shows you an example of this. Is a really interesting map showing you where virtual water gets imported and exported. Yeah. So have a look at the legend. Remember, the first thing you want to do is look at the title. There isn't one, so we've got to figure it out. Now we look at the legend. The legend is showing us the net virtual water imported. So if it's a negative number, that means it's being exported. If it's a red number down here, it's being imported. So the deep red is lots of water is being imported in food and products. So Europe is importing heaps of water from the rest of the world by importing food and other products. Yeah. Australia's in green, meaning we export our water in the form of food and products. And the example that I gave you earlier was rice. So Australia grows rice, uses heaps of water to grow that rice, and then we sell that rice overseas. And bye-bye water. Bye. So let's talk about water footprint. The water footprint is the amount of water that's used by you or by a whole country to run its lifestyle. And that is domestic water use plus imported water use. Yeah? So as mentioned before, all the water that's used domestically, i.e. in Australia, to create all the food and products that you need for your lifestyle, plus any water that's imported by importing food or importing products. Three little bits of terminology here I want to tell you about. We've got blue water, and that's all the water that's in rivers and lakes and aquifers. Remember, an aquifer is an underground water source, like an underground cave with water in it. Where if you have a bore or underground water, it's sucking water out from an aquifer using some kind of tunnel. We've also got green water, and that's all the water that's stored in plants from rainfall. And then we've got grey water. That's just water that humans have used that's polluted. So like grey water might be water that you've flushed out your toilet. Grey water might be water that you've used in a factory process or whatever. It's wastewater. And you can clean that stuff up, recycle it, reuse it. Let's have a look at a graph. A lot of things missing in this graph to help us understand what it's showing. Most importantly, there's no title. Now, thankfully I can figure out what the title of this is because I found it. So this is showing the water footprint per person per day. So the higher the bar, the more water is used by people in that country. The lower the bar, the less water is used by people in that country. So if you have a look there, United Arab Emirates, heaps and heaps of water is used by them. Why is that so high at United Arab Emirates? Remember, it counts towards your water footprint if you produce something in that country and you export it. And what does the United Arab Emirates export? That's where all of the oil comes from. Heaps and heaps of oil from United Arab Emirates. It's in the Middle East. The USA, really, really rich country, high resource use. They also export some oil as well. Have a look right down here. You'll notice that richer countries use more water than poorer countries down here, like Bangladesh and China don't use as much. And there's us there in the middle. Here's the global, so that's the world average. If you took all the countries together, found out the average, and Australia is above that average, so we use more water than the average person. How about a map? This is the total water footprint per person. So just to translate this for you, M3/YR/CAP, meters squared, that means cubic meters. So a cubic meter is, imagine a giant cube that's a meter by a meter by a meter, like a big dice, yeah, like that. But it's a meter by a meter by a meter. That's 10,000 litres of water, I think. Anyway, the /YR, that means per year, and then the /cap, that means per capita. Capita is just a Latin word for head, and so that means per person. So it's tens of thousands of litres per year per person, but basically it just means how much water is being used per person. And so again, we look at the legend. The countries in green don't use that much water per person. The countries in dark red use heaps of water per person. Where's Australia? What colour is that? Orangey. So we're sitting in the 2,000 to 2,500 cubic meters per year per person in Australia, and that's quite a lot of water use. Again, you can probably say, to interpret that graph, the richer countries use more water than the poorer countries. Although the Europeans don't seem to use quite as much as Australia, North America. Anyway, right, here's your activity. It's all about this graph. So there's a graph there. I want you to answer these 4 questions about it. What could this graph be used for? What's the average water use of these products? How are you going to work out the average water use of these products? Remember how to work out an average is you add up all of the elements and then divide by the number of them. So you're going to add up all of these numbers and then divide the answer by 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And that'll be your average water use. I'm sure you know how to do an average. You're very smart. Third, how many products use more than 5,000 litres? So 5,000 litres would be about there. How many products use more than that? And finally, and I kind of answered this one a bit earlier, why do you think meat uses so much more water compared to vegetables? It should say compared, not compare. Anyway, let's watch a video. This one's all about virtual water. Take it away.
Question: what do the following objects all have in common? The answer is water. Water is used to make every product on Earth. On average, a cup of coffee uses 140 litres. A shirt uses 2,700 litres. A bottle of beer uses 75 litres. Even the microchip in your computer uses 32 litres. Wherever in the world we live, our lifestyles and livelihoods depend on water.
And finally today you're going to write down reflection activity and you're going to draw a grid like that. You're going to write those 4 words: strengths, weaknesses, opportunities and threats. This is what's called a SWOT analysis, SWOT, because it's S for strengths, W for weakness, O for opportunity, T for threats. I want you to come up with at least 1 strength of virtual water, 1 weakness of virtual water, 1 opportunity we might have for virtual water, and 1 threat for virtual water. Yeah, I could give you examples, but I'm worried that you might just copy my examples. So have a go with that. A SWOT analysis is a really common thing used in geography and in the world in general, so it's quite a good habit to get into. Anyway, thank you so much for participating in my lesson. Don't ever stop keeping it real.